Okay, so we are moving into the 7th grade curriculum at this point, and you're going to be like, Ms. King, this seems very similar, very familiar, which essentially it is, because ultimately 7th grade is just a build off of 6th grade. So we are going to start with some easy stuff that we've already talked about, which is going to be the simplifying expressions, and we're also going to be covering distributive properties today. So today is really going to be more of a review going into tomorrow, which is going to be distributive property with negative numbers, which is where it gets a little bit different. So let's go ahead and fill in some of these blanks. All right, so a mathematical phrase that contains numbers, variables, and operations is an expression. An expression does not, make sure you have that in capital letters, have an equal sign. And please understand, underline equal sign. Struggling today. I think I had a mini stroke. All right, a term is a constant or a variable. Lord, it's gonna be a day today. I can't spell the day either, just a heads up. And an expression that is separated by a plus or minus sign. So a term can be a coefficient, which is a number and a letter. It can be an exponent, it can be just a variable, it can be just a number. As long as it is separated by a plus or minus sign, then you know it is a term. A couple different examples would be 6n is a term. Why is 6n a term? Why is it a term?
Because it doesn't have plus or minus in between.
Right, so what operation is actually going on between 6 and n?
Multiplication.
Yes. All right, what about 14? Is 14 a term? It's an example, it's a term. What is 14? 14 is also known as what?
Oh yeah, constant.
A constant. Okay? And then the last one is with an exponent. So you have 2x squared. All right, so coefficient is the number in front of a variable. So we'll just use this one. This is your coefficient, the 6. And then like terms, it must have the same base or variable and the same exponent or power. So you cannot combine 2x squared plus 3x to the third. You cannot combine those two. Why? Why can we not combine these two? Mason?
So they're different decimals.
Right. So their power is different. In order to be able to combine those two, the powers would have to be the same, and you're only combining this part of it. Does that make sense? Okay, so if the power is not the same, even though the variable is the same, if the power is not the same, you cannot combine those two numbers. All right, so we are going to identify parts of our problem down here. So the letter, start with the easy one, is what? Raise your hand and tell me. Cooper, is your variable. Okay? This subtraction sign right here is known as what? Christian? Your operation. This 9 all by itself is known as what? Ace?
Coefficient.
Nope. All by itself. Starts with a C. It's a number by itself.
Oh,
What-
constant.
Yes. Alright. Then, this number right here connected to the variable. What is that called? Gabriel? No. Y'all pay attention. It is a coefficient. Now, 4D is what? 4D is what?
A term.
It is the term. And then 4D minus 9 is what? 4D minus 9 is what? What do we call that? Alexa? Yes. Alright, so these three boxes, it says use the definitions above to help you complete the following. So for number one, it says give an example of an expression with three terms. Okay, so someone just give me an example of an expression with three terms. Joseph.
I'm gonna say 4 M.
For M,
Oh, wait,
as
for-
in like Michael,
N
as in Nancy.
Yeah.
Okay, 4N
plus
plus,
6.
okay,
Let's
Gotta-
say
gotta have one more.
minus 10.
10, perfect. That's it. It's got three terms. It's got the operations separating, which are addition and subtraction. Okay, questions about that one? Alright, so the next one says list all the terms in the expression below. So, listing all the terms. So we have 8C. What comes next? What comes next? Haley? No. Why is it not 5?
Because that's a constant.
Nope.
But that's a coefficient.
Nope. Is the number 5? Is it what?
Negative
It is a negative 5. And how do you know it is a negative 5?
Oh, that's right.
What's in front of it?
Subtraction.
Right. So it is, remember, the operations go with the number to like the right, left, right? Right? Sorry. I said that completely backwards. Let me say it the way that I always say it. The operation goes with the number, so like if the number is in, never mind. The operation is in front, that operation goes with the number right next to it. So this is minus 5. All right, the next one is 4c squared. So do we have to put the plus 4c squared? No.
Yeah.
Right, because we already know it's positive, and then obviously we don't have to put the 2b. Alright, now, C says circle the coefficients in the expression below. So circle all the numbers that go with a variable. What do you need to include with those numbers though? Not the variable, no,
The
because you're
operation.
circling the what?
Oh, that's
The operations. Alright, so the first one, we're circling 5. Raise your hand and tell me, what are we circling next? Cooper? No. No. Gabriel? Yes.
I thought you said you didn't have to include it.
You don't have to include it when you're identifying like the term. But I want you guys to understand with these that it's like for the next one. Are you guys good?
Yeah, I was helping him out. He kept rolling up the hill.
You struggling. Struggle bus is real over there.
I'm sorry today.
And Cooper's like, oh God, she's gonna see me
Get it,
talking. Oh my
get it.
God, she's gonna yell at me.
Good.
I am making you circle the operations in this one just because this last one is a minus 2. So I want you to understand that it is a negative 2. Okay? Alright, so it says give an example of a like term for each of the following. So you have A, B, C, and D. So this is just a number, so what would be a like term to just a number? Michaela? 10. Alright. What would be a like term to 3B? Cooper? 5B. What would be a like term to negative 5A? Christian? 10A. And what would be a like term to x squared? Mason?
5 squared.
Not 5 squared, it's gotta have what in it?
B squared. X squared.
5x squared.
Yes. Alright, so again, this is just kind of a refresher of stuff that we've already talked about this year. So now we're going to slide up to the top right side. So we are going to talk about simplifying expressions. Simplifying expressions is just that. You're doing what when you simplify an expression? You want to make it what? Smaller. Alright, so we can simplify algebraic expressions by combining like terms. And be careful when you're combining like terms to check the sign that is in front of them, of the term, sorry. That's what I was trying to say over there, it just didn't work out. Alright, so it says, the Robinson family ordered snacks at the state fair. They bought the following drinks, D, pizza P, and ice cream C. Write an expression to represent their purchases. So with this, I just want you to take and pick whatever color you want to represent pizza. I don't care what it is. And for every pizza that you see, you're simply going to put a P on that piece of pizza. Then pick a color for the soda, and you're gonna put, or drinks, I guess. And you're gonna put a D on top of that one. And then for ice cream, you're gonna put a C. Hold on. So now you are going to write in the same color that you picked pizza, however many P's you have up there, you're gonna write that. So you're gonna write P plus P plus P plus P plus P. You should have 5. Then you're going to add, let's do the drinks. So how many drinks do we have? 3. So I'm going to do plus D plus D plus D. And then the last one is C. So I'm going to do plus C plus C. Now, can we combine those 5 P's?
Yes.
What number is invisible, but because it has a P in that problem, that expression, we know that it's got a value, but what number is in front of a variable if it doesn't have any numbers at all in front of it?
A 1.
A 1. So Ethan, if we have 5 P's, how many P's do we actually have?
5.
So our simplified expression is going to be 5P plus how many D's do we have? Gabriel, unless you want me to absolutely lose my mind, you better throw that in the garbage. How many D's do we have? We have 3, so we're going to do plus 3D plus how many ice creams do we have?
2.
Christian? 2. Alright, so in your own terms, explain how this example can relate to an algebraic expression. So go ahead and write that. I'm going to give you a minute. Go. like to share what they wrote? You don't know what an algebraic expression is? You just wrote one. 5p plus 3d plus 2c.
It's just an expression with a couple letters.
Thank you, Cooper.
I don't think it's gonna go well, but we'll see. I put that because length and algebraic expression you have to combine like terms.
Say it again.
Because you have to combine like terms.
That's what I put.
That's it.
That's what I put.
That's it. It's not scary, y'all. I mean, if you have something along the guys, if you have something along the lines of because you have to combine like terms or you're combining like terms, that's all. That's it. Not rocket science. Now, this next part, it says choose, or it says color code or use a shape to identify each term and combine like terms. The first one has been done for you, and questions 5 through 8 simplify the expression. Now, on this piece of paper right here, you are using color. The paper that I just passed out to you is homework. You may use shapes or you may use color. You cannot just circle. Does that make sense? So if you don't want to use color on your homework, that's fine, but you gotta use shapes then. Does that make sense? I'm not requiring you to do homework or to do colors, but I am requiring you to make sure that we can tell the difference. All right, so for the first one, they did 14b and 6b and they added those two. Then they did plus 8 minus 12 and got minus 4. So for the next one, we have 4 and 2 times j plus 6 and 7 times j minus 5j minus 5. So what can we combine? What can we combine? Christian?
2, 4, 8, and plus 6 plus 7.
Okay, anything else?
Also, negative 5 there.
Yes. All right, so we can add those 3 together, and then obviously this minus 5 is by itself, but he's still part of our problem. All right, so what is 4 and 2 tenths plus 6 and 7 tenths plus or minus 5? So what's 4 and 2 tenths plus 6 and 7 tenths? I'm sorry, y'all raise your hand.
10 and 9, or yeah, 10 and 9.
10 and 9 tenths.
10 and 9 times J.
J, yes. And then minus 5?
5 and 9 times J.
So 5 and 9 tenths J. And then what do I do with this minus 5, Caleb?
You just like write it next to
I just bring it down?
Yeah.
Because there's nothing I can do with it. Okay, but we don't forget about it.
Yeah.
All right. All right, the next one, 20C plus 8D plus 10C minus 5D. All right, what can I combine? Jackson,
20C and 7C
not just 10C.
and 8C.
No, not just 10C.
Oh,
How am I gonna, yeah, well, plus, because that plus is telling me what?
that is positive.
No, it's telling me what I'm
Oh,
gonna,
that you're adding.
yes.
Okay.
All right, woo, that's tough. All right, and then what else are we doing?
8C and
No, child. Well, technically, yes. And then what?
and then minus 5C.
All right, so Justin, when you add 20C plus 10C, what do you get?
30C.
And then when you do 8D minus 5D, what do you get?
I don't know if it's negative 3D or just 3D.
I'm sorry, that's why you include the plus. 3D. 3D. It's 3D. 3D. 3D.
She's already standing up and writing stuff.
Is that Jackson?
Yes.
Yeah, is that
That's
you?
my head exploding.
Oh, okay.
Oh.
Oh.
When you just simply throw it the other way, what happens?
8 minus 5. Oh, so it's 3D.
Oh my god.
Wait, is that an
Yes.
Are you serious?
Yes, I'm bald because all my hair just flew off my head. Alright. So, 5, 6, 7, 8. Guys, hush. 5, 6, 7, 8, 9, and 10 are also part of your homework. Put this to the side. Make sure you have a homework. You right? Charlie. If y'all don't be quiet, I'll make it do tomorrow. Alright, so moving into distributor property. No, not for this one.
That's good. That's a good thing. Yeah.
Yeah, he can fit in places.
Yeah, but then again, he needs a step stool to reach the top shelf.
So, no,
And he's allowed
Just kidding. I wish you put him on the high chair.
Jackson.
Alright, go ahead, turn the page. Title. So your homework's due tomorrow. At this moment in time, all homework is due tomorrow, since we don't know how to wrap it up and come back. Hopefully you can, in the next 22 minutes, persuade me not to make it due tomorrow. Get this copied down. Guided notes, distributor property 3/30. And get the piece of paper out that I just passed out to you. Alright, so it says Taylor and Hash each simplified the same expression using different approaches. Use their work, to answer A through C. So, how does Taylor's approach differ from Hash's? You need to write a sentence or two about this. Complete each student's work, what do you notice? And then, using Hash's approach, how could the expression 7 times x plus 2 be simplified? Alright, you're working as you're in your group, sorry. And I'm gonna give you 3 minutes. Go.
Hi guys. Guys, yeah.
He uses order of operations.
Wait, is tax being distributed property? She might be.
They are on the same.
Okay guys, so what do you notice for
Oh, we are?
Yeah, we do that.
Okay, so they've got you were looking at
Yeah, I think we'll have to, I think Matt is using distributed
yeah.
love it. Yeah,
It was hot earlier.
it was. And we went outside earlier.
You would get.
You guys have 50 seconds. If you're done, stand up.
Guys, you can watch the approach, you get 7 eggs.
Oh, crap. He said that, that happened.
Yes.
Wait, I haven't done this all day today. Well, that was disappointing. Oh, my knees are gonna crack again.
I went to go throw something on. I was very careful not to put it.
That was more disappointing. That was.
He didn't want to get you on video. I'm camera shy.
He didn't want to break your iPad screen.
You're right. Alright, Hash. Alright, so what did we say for A? What did we say for A? A.
Taylor added them together and then multiplied, but Tash kept them separate and just multiplied them and then added them.
Hash, you said multiplied, then added.
Yes, she multiplied them separately and then added them.
So basically.
Alright, complete each student's work. So when we do all this, what do we end up with for Taylor? Jeremiah? Alright, when we do all this, what do we end up for Tash? Aubrey? Okay, and then using Tash's approach, how would you simplify 7x or 7 times x plus 2? Christian? No. Well, yeah, I see what you're doing. Or you could just make it like that, without all the parentheses, because that means the same thing, right?
Yes.
Okay, so 7 times x, and then what did you say?
Plus 7 times 2.
And then what do you get? Well, what's 7 times x? And then 7 times 2. Okay. Alright, so distributive property. It allows the property, so distributive property allows the number outside of the parentheses to be distributed to the terms inside the parentheses. So again, remember that arrow, you just draw it, and every arrow is multiplication. Okay, so you're multiplying. The biggest difference between 6th grade and 7th grade, obviously one is the negative numbers, but 2 is you have more than just 2 numbers or 2 terms inside of your parentheses. You can have 2, you can have 3, you can have 4. So there's just a whole lot more. And then obviously, if there's like terms, you're distributing and then using like terms to combine. Okay, so you're putting a lot more skill into one thing. Cool. All right, so number 1 says, each of the 4 members of the Robinson family ordered a drink, 2 slices of pizza, and an ice cream cone. As shown, distribute and write an expression to represent their order. All right, so we're obviously going to distribute the 4 into these. Okay, so what would your, like if we're doing 4 times drinks, right? So that just becomes 4D plus, where did I get my plus sign from?
In the parentheses.
Inside the parentheses, just want to make sure. All right, now, am I just going to do 4 times P?
No.
Raise your hand and tell me why. What am I actually doing, Jason?
You're multiplying it by 2 of that 2.
Why?
Because
Well, why am I why didn't I multiply the drink by 2?
there are actually 4. And there are going to be
But why am I multiplying by 2? So why didn't you just say it to begin with? So, because there are 2 slices of pizza, technically this is 2p. So we're going to do 4 times 2 is 8p. And then how many ice creams do you have?
2. Me 1.
We have 1, so then it just becomes 4c. Alright, this is the area model. This is one of those things I'm going to show you, and we're going to keep it right on moving because honestly, I don't like area model, but sometimes it's really good for other people. So you take this number and you multiply times that, and you take this number and multiply times that. So this becomes 5 times 3x and 5 times 2. So this becomes 15x plus 10. That's how you use the area model. The line always means plus. Why are you blowing papers around, River? I don't know. Alright, so this one, I want you to do on your own. Stand up. Excuse me when you have it. River, Jackson, Haley, and Brock. I just forgot to give these to y'all yesterday. Very poor hearts.
Oh, okay.
Or, I guess 2 days ago. I don't know. Alright, what do you get when you do 7 times x? What do you get? 7x. So you get 7x. Alright. And then what do we get when we do 7 times negative 9? Kayla.
Negative 63.
Does everybody understand why I did not put a plus there? Is there anybody who doesn't understand? Alright, so it says simplify the following expressions by using distributive properties. So you are going to distribute your 5 in. So it's going to be 5 times 6x plus 5 times 9. What do you get when you do 5 times 6? Jeremiah. 30. So this becomes 30x plus, what's 5 times 9?
45.
45. Alright, the next one. 4 times 3k minus 4 times 2.
Well, wouldn't it be negative 2?
We're getting there. We're getting there. Alright, so with this one, you gotta be careful. What do we do? What do you think, Jackson?
You do 4 times 3k to get 12k. And then minus. I wrote Alexa, Aubrey, and Hunter.
Yeah. What's 4 times 2?
8.
And is it a negative 2 or a positive 2?
Is it negative 2? Okay, I got some.
That's it. Because you're not, you're only looking at the inside. Does that make sense?
Yeah. You really don't have to figure out if it's negative because it's going to be the same either way. Since there's a subtraction sign.
As long as there's not 2. If there are 2 subtraction signs, like if the negative was, if it was negative 4 and you're distributing your negative 4, and then that changes it. And that'd be a
Because it's the
positive.
first number.
Right. Alright, and then the last one, number 6. You end up doing 1.5 times 6t plus 1.5, I have to write a 5, times 2. Alright, what do you get when you do 1.5 times 6t?
Oh, you get 9.
Plus 1.5 times 2?
3.
3. Alright, 7 through 12 are part of your homework. So factoring and expression. So this part is just talking about using the GCF. So instead of it being with the number on the outside like these all are, you are having to find the number that will go on the outside. Does that make sense? So you're just finding the GCF of those two. But it says expressions can be factored to remove the common factor. This is how we undo the distributive property. So determine the greatest common factor and then remove the greatest common factor by dividing each term by it. So looking at this example, you have 4x and you have 16. What is the GCF, or the greatest common factor, between 4 and 16? Jack? 4. So our GCF is 4, so we put 4 on the outside and we say, well, 4 times what gives me 4? 4 times what gives me 4? 1. So you can put a 1x, or you can just put it just an x. Plus 4 times what gives me 16? 4. Alright, so that's just finding the GCF and putting it on the outside. Alright, so number 13. What is our GCF between 6 and 2? Put that piece of paper down. What is our GCF between 6 and 2, Charles? 2. So Charles, 2 times what gives me 6? So that becomes 3a plus 2 times what gives me 2? 1. Okay, that's all it is. It's not that hard. In a way, I kind of like this way better, as long as I make sure I get the right GCF. All right, the next one, 24 and 9. What is the GCF between 24 and 9? Christian? 3. So 3 goes on the outside. So 3 times what gives me 24? So that becomes 8x minus 3 times what gives me 9? Perfect. All right, and then number 15, it says 10x plus 35. What number goes into both 10 and 5? Michaela?
10.
No.
But can it be multiplied by like
No.
3? Okay, fine.
Remember, GCF are all the even numbers that you can multiply together.
Oh, okay. 5.
5. So 5 times what gives you 10?
2.
And then 5 times what gives you 35? Alright, don't worry about 16, just cross that off. Please get your notes copied, printed, not printed, good lord. Glued in, because you do not want to lose these 2 pages. The other 2 pages are homework. At this moment, you have about 4 minutes before we are leaving. You are not moving, you are working. Glue that in and then get started on your homework, and I will let you know before we leave today if you are due tomorrow or due on Monday. So persuade me to be due on Monday.
Can I just do all of it tomorrow?